Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the last question of this paper, JEE Advanced Physics paper 2017. So let us solve the last part of this question. Students, the question is, this is the last question of this paper, the minimum value of omega naught below which the ring will drop down. That means if the ring is not falling down, that means its weight has to be balanced by some force, that is the vertical force. And what balances the vertical force? So obviously it might be friction, might be some component of the normal direction that we don't know, that we have to calculate. And what is that minimum value of omega naught below which the ring will drop down? So while it is rotating, what is the omega? That we have to find out. Now if I look at the situation, actually this is the ring and our finger is like that, moves in a circle and like this. So if you just remember the diagram over here, this one, this line, suppose this angle is theta, and the normal reaction will be in this side, normal reaction, and the ring. This is the normal reaction, and it will have components. Obviously, the weight of the ring is mg downward, so this has to be balanced here. This should be mg over here, I can write, and the friction should be in this direction. The friction should be, because this is in a inclined plane. This line is inclined, and friction, if the ring has to slip down, then it has to slip down like that. Then friction will be in this direction. So friction will be in this direction. Friction is mu into n. N is that I have to write what is n over there. Now this has this mu n has two components. I'll write here along this direction and along this direction. I have two components. This is mu n. This one is mu n cos theta, and this one will be mu n sine of theta. This is our n, this is theta, this is 90, this is also 90. So if this is theta, this is 90 minus theta. If this is 90 minus theta, this would be theta, because this 2 is 90. Now this n is resolved into two components, one along this line and another along this line. This theta, so this becomes n cos theta, this one is n cos theta, and this vector will be n sin theta. So just let me repeat that the frictional force here is resolved into, this is how the ring is actually, I'm just drilling like this, and the ring is rotating like that. So the ring is rotating. Here the friction is divided in two components like that. This component is mu n cos theta, this is mu n sin theta. Similarly, the normal reaction is also divided into two components. All the vectors are resolved in these directions x and y. this is inclined, the frictional force was in this direction, this was resolved into this and this component. The normal reaction you can see here was like this, it has also resolved into this component, this component. Now, because we need to have a centripetal force which is to be provided for rotational motion. So for rotational motion, there should be a centripetal force, and the centripetal force can be written as, so this two will balance out the difference, this minus this is balancing this, or this is this plus this. So first equation I'm getting is mu n cos theta minus n sin theta. This balances the weight mg. The difference will balance this weight. Similarly, the sum of these two will provide the centripetal force, that is mu n sin theta plus n cos theta provides you centripetal force, that is m v square by r, or m omega square r. That omega is your omega naught square, r is r minus r. Because with respect to this point, this is rotating with omega and this is also rotating with omega naught. If this is rotating with omega naught, then this is the actual radius r minus r. Okay, the center of mass of the ring is rotating about this point, r minus r. If I divide these two equations, equation 1 and this is equation 2, if I divide 2 by 1, what I will get? Equation 2 divided by equation 1 will give me, this right side will give me omega naught square r minus r divided by g. You can see here, this divided by this, m will cancel, this divided by this will remain, and this one will become, n will cancel out, n common cancel out, mu cos theta minus sin theta divided by mu sin theta plus cos theta, mu plus cos theta. It says that what is the minimum value of omega naught? This minimum is when this is to minimum, so this has to be minimum. For this has to be minimum, this has to be maximum. For this has to be maximum, theta should be 0. For minimum omega naught, theta should be maximum. That means it should be, this is 0, this is mu, this is 0, and this is 1 by mu. Okay, for this to be, so dividing the two equations, you can divide these two equations, 2 by 1, what will get? Equation 2 divided by 1. This gives me, the left part will be mu n sin theta plus n cos theta divided by mu n cos theta minus n sin theta. Right side, what I'm doing, I'm just copying it. This divided by this factor will come first, this factor will come second, and this divided by this, m will cancel out, and it is omega naught square r minus r divided by g. Now n will cancel out and this becomes mu sine theta plus cos theta divided by mu cos theta minus sine theta. This equals to omega naught square r minus r divided by g. Now this is the omega and this g and r over r will be multiplied here and take the root. This is the omega with which it is rotating. Now the question is, what is the minimum omega for which that this will not drop down? So we want this omega not to minimum, and for this to minimum, the angle here it should be maximum and this should be minimum. For this to be minimum, this has to be this has to be maximum. For this to be maximum, this angle should be 0. If I put angle is 0 over here, or I could have divided cos theta in everywhere. Anyway, put theta equals to 0. For theta to be 0, omega naught is minimum. Then this becomes 1 divided by mu equals to omega naught square r minus r over g. So from here I will get the expression for omega naught square, which is g over mu divided by r minus r root if I don't take omega naught. So finally omega naught is g divided by mu into r minus r the root. This is the final omega I am getting. So this is the omega naught minimum. So the minimum value of omega naught is g divided by r minus r root. G divided by mu into r minus. So this one is the correct answer to this question. So this is the end of the paper. Thank you.